So one of the important things about GC is how do we get the sample into the GC? Now we've had a look at the flow paths and everything else, but now we need to talk about how do I get my raw, neat sample in a form that is acceptable to the GC. So the big deal in the GC world is that the sample must be volatile. You got to vaporize it. Anything that does not vaporize, you leave behind in the inlet. So ideally, we want to get a sample that's 100% volatile. That is the ideal situation for GC. So typically, we're going to take your sample, dissolve it in a solvent, and then inject that. I'll give you some ballpark ideas. I would look at making a 1% solution. 1%, which means 1 gram in 100 mils. So weigh out a gram, take it up to 100 mils. There's your 1% solution. 100 mils is a lot for me to work with. It's not to work with, but to get rid of, to be able to throw away. So I prefer working on a 25 mil or even a 10 mil. I don't go below 10. I got some 5 mil ones. I don't really trust them as much, but I use this one a lot. So 25 mil volumetric, which means you put in 0.25 grams, dilute up to the mark. What do you dilute with? Well, whatever the sample is soluble in. The most typical thing is going to be hexane, just because in GC, everything we do in GC is volatile. Volatile compounds all tend to be pretty nonpolar, so it's a good match. So that's why hexane is probably the most common solvent in GC. But again, the goal here is you must dissolve your sample. So if your sample's more on the polar side of things, methanol is a favorite. So when I'm looking at drugs of abuse, we typically will use methanol as a solvent because it'll dissolve anything that's meant for the human body. In between we have something like ethyl acetate. Keep in mind there's hundreds of different solvents because we're talking about GC. This is applied to 1 million different samples, which means there's 2 million different sample prep approaches. But the simple concept is you need to get your sample, dilute it in a solvent, everything is volatile, and then we're going to inject 1 microliter of that onto the GC. So typically, you're going to make up your sample, and you're going to put it into a 2 mil vial. Now, they're actually 1.8 mils, but we call them 2 mil vials. This is the sample that all HPLC and GC autosamplers will take, the little 2 mil vials. You need at least half a mil for the autosampler to do its thing. So I prefer to have 1 mil in these vials, maybe 1.5 mil in these vials, because if it's too far down, depending on your autosampler, the needle may not reach it. And that's a miserable thing to troubleshoot, to try and figure out why you're getting no peaks because you're actually getting no sample. So at least 1 mil in these vials, and life is good. I like the ones with the little the white markings on them because I write with pencil on my vials. I do not use markers. So sitting around here, of course, we all love our Sharpie markers, but the Sharpie marker, I could smell it. Well, if you could smell it, the GC can detect it. So I personally don't like using these around my samples because we are talking about a very sensitive technique. Those vapors can get into the sample vial. That's why I prefer using pencils or wax pencils. And that way I could write on the vial and then not worry about any volatiles. So typically we put our sample in 2 mil vial. We put the cap on with a septum. I like the screw caps just because, I don't know, it's me. I like the screw caps. Many people will use the crimp caps. That's fantastic. You use the crimp caps. You make sure when you crimp it, make sure it's tight. You want to make sure this is not leaking. We don't want the solvent to vaporize because if that happens, then we're going to change the concentration. So most people in the world are going to put their GC sample in a vial like this, put it on the autosampler, let it do its thing. But that doesn't account for everyone in the world. Some people will choose what's called Headspace GC. Now, Headspace is fantastic. We're going to use a big vial. This is a 20 mil vial, not a 2 mil, but a 20 mil vial. And this vial, the idea is we're going to put a really small amount of sample, maybe 1 or 2 grams or 1 or 2 milliliters. So the sample's down here at the bottom. We're going to put a cap on it, and we'll crimp this guy shut so it's nice and tight. And then the sample itself, we're going to analyze the vapor above the sample. So we're not going to go down and touch the sample. We're going to analyze the vapor above it. So let me give you a good example. If I wanted to analyze soil, dirt, for gasoline, how would I do that? Well, dirt, I can't dissolve it. I can't put it in this little vial, and if I try and inject dirt, it's going to mess up the GC. But in this case, I just care about the vapor above the dirt, right? The dirt smells like gasoline, so that's what I'm going to get here. So Headspace is big for looking at residual solvents in pharmaceuticals, also big for looking at alcohol in blood, because blood, again, pretty messy sample. You don't want to inject it on a GC, but I could put a couple of drops of blood in the bottom of this vial, and then I can measure any volatile components, such as ethanol in the vial. So that takes you through some pretty good looks at sample prep for GC. Now, if you have this much interest and you're still sitting here listening to me, you should probably take a look at the GC, the video that I did on GC operations, because in that I take a complete look at everything you need to know to operate a GC. Also, I invite you to join us at Axon Lite. You'll see a link down below. And Axon Lite, I got a bunch of free videos in there that goes into a lot more detail on all these different subjects.